Welcome to another edition of Coffee with Developers. I'm here with Clement Farabet from Google, and today we're going to talk about open source AI models, including Gemma. So can you quickly introduce yourself? What are you doing? What you've done before? How did you get into that whole AI game?
Well, thanks so much for having me here, Chris. It's really great. So my story with AI started some 20 years ago. I was still an undergrad, and I sort of started reading books about artificial intelligence, neural networks, and I just got completely fascinated by this notion that you could sort of train a neural net to achieve seemingly arbitrary goals. Even though back then these neural nets were very limited and hard to train, there were early proof points that showed that they could do amazing things. So I guess I got the neural net virus at this stage. This was in the sort of mid 2005 ish. And I started working on them. And specifically, I started building this sort of neural net processor to accelerate neural nets and sort of like embed them into things like, unmanned helicopters. And that's how I got to meet Yann LeCun, who was then a professor at NYU. And he invited me to sort of like come over as a research scientist initially. And then I ended up doing my PhD with him. And I sort of spent 5 absolutely amazing years with him, building sort of, neural net processors, compilers for neural nets, and then eventually started sort of training these end-to-end neural nets to solve fairly complex computer vision tasks. The thing I was the most proud of then, and that was in 2010, 2011, was that we trained this end-to-end neural network to essentially fully classify every pixel in a 360 multi-camera stream, and sort of like completely segment and classify parts of the scene so that a robot could use that to navigate in complex environments. We then ran that a neural net on an FPGA with a computer that I had completely designed from the ground up. And this was such a fascinating point in time for me, because we would sort of build these systems completely manually. There was a very low belief that neural nets would ever become a thing. It would take us something like 3-4 weeks to train one of these small neural networks and this multi-CPU cluster. We started using GPUs then, and what happened is that there was this inflection point around 2011, 12, 13. AlexNet is this famous neural net that came out of the University of Toronto, Jeff Hinton's lab. They managed to sort of drastically accelerate the training of these neural nets on a multi-GPU, 2-GPU system then, and show that they could solve these very advanced computer vision tasks, this problem called ImageNet then. And so it accelerated the field. Like, more people got excited. I had started a company then called MadBeats, where my goal was to sort of build a search engine for visual content. We sold that company to Twitter, the social media. And since then, I've been sort of obsessed with how do you build large-scale neural nets that can solve all sorts of tasks at the sort of intersection of human cognition and human perception, and these sort of offline digital systems. I then spent 6 years at NVIDIA building, AI infrastructure, particularly focused on self-driving cars with Jensen. This was quite exciting. And then when ChatGPT came out, I reconnected with my very close friends at Google DeepMind, Corey in particular. I was sort of sitting next to him when we did our PhDs back at NYU. Raya, Demis, and I've been super excited to come help them essentially putting Gemini into all sorts of product shapes and figure out what would be the future of AGI here.
Wow, that's a lot of like pedigree that you have there, and a lot of things that you've done before. It's interesting because at that time we were still wondering about like if there's going to be a third AI winter. Because I mean, it started in the 50s and 60s, and then the machines were always not fast enough, and we were just going on like, we have to wait until the computers are fast enough to do the things that we want to do. And now we have like mobile phones in our pocket with like 12 GPU cores, and you're like, and it's just incredible how fast that came about with the changes that said, as you said before, some of the nets, the neural nets that we created back then. I think the big breakthrough was also the Transformers paper. That basically then found like money coming in and seeing the benefit of it. I remember that when I started in the whole thing, like when it became like 2015, 2013, it was all APIs. You basically had like facial recognition APIs. You had like APIs that could find landmarks and these kind of things. You did a bit of like language analysis and natural language processing, and then the Gen AI thing came about, and out of a sudden it became like a thing built into systems rather than just like an API to play with or a network to actually try out yourself and install yourself. So you're now working in Google on the AI space, and there's a lot of products that you have, and it can get a bit confusing about the naming. So can you give us a quick overview of what is what? Like what's Gemma, what's Gemini, and how do they coexist? Which one can I use, and where do they overlap?
Yeah, that's a fantastic question. So I think the best way to understand the way we're approaching the market right now is we're really trying to build models that cater to every sort of possible need across the spectrum. And the way we've approached it is that on the one extreme, you have these very capable, sort of like the best models in the world that require multiple TPUs, these fairly complex deployment patterns to run. That's essentially Gemini. So we're putting that behind an API. And our goal there is to sort of like ensure that, the entire execution path, the serving, the multi-TPU setup, the shape of the API, everything is sort of abstracted and runs extremely well, makes the best use of our TPUs. And then on the other end of the spectrum, you have all these sort of like ad hoc, bespoke, personal device deployment environments. So like AIs that are going to be running on your cell phone, on your personal computer, maybe on arbitrary sort of IoT devices. That's where we've introduced Gemma. And the idea with Gemma is that we're sort of giving you the weights. The inference code is open source. And we're expecting that folks are going to be very creative in how they deploy these models. And then what I love about this sort of dual approach is that we have a way to both create localized AIs that can be quite customized and deployed in all sorts of different ways. And then on the cloud side, we have the most powerful, capable model that can take maybe multiple minutes to think and reason through something. So at I/O recently, we announced this new capability of Gemini called structured thinking. So you have these use cases where Gemini is going to be thinking for quite a bit of time to speed out some results. What I love about this is that, you have applications I think we're going to start building now. It's already the case in robotics, for instance, where you have a system like Gemma at the edge that's doing a lot of fast local processing at 10 hertz, for instance. But then it's going to be able to offload more complex tasks to Gemini cloud side when it needs more deeper answer, deeper reasoning, deeper thinking, or even access to search results and so on. So I think that's how we're dividing the world. The basic concept is models that are going to be deployed locally on a personal device. That's Gemma. It's open. And then models that are cloud side, quite complex to deploy. That's Gemini. They're closed and they're behind an API.
Feels to me like a bit like what computing and hosting used to be. Like I did like local on-prem hosting, and when I needed like hard calculations like batch conversion of video or something like that, I used the cloud service for that, and then I got the data back and used it. So it feels like the question then is like, how often does Gemma, my local version, how often do I need to update that, or no, how can I even update one? So will the new capabilities be more in the Gemini space, or will they also be reflected in new versions of Gemma that I can install locally?
So typically, Gemma is another thing I forgot to mention is that because we're targeting small sort of like personal devices with Gemma, you'll notice that we've never really attempted to train very large Gemma models. The largest Gemma model we have is 30 billion parameters, and we picked that size so that it would still fit in one single NVIDIA H100, such that it would be very easy to deploy. And so the approach we have is generally we sort of distill from Gemini to create Gemma. And we, so there's this sort of like train of capabilities moving from Gemini to Gemma over time. And then there are things that we believe are sort of like not really sensible for the on-device world. And we won't move them to on-device. Like for instance, extremely long context. Most likely not very relevant to local embedded environments. Whereas for the cloud side, you want Gemini to be able to deal with extremely long context, be able to ingest entire collections of books, videos, and so on. And so I think we're going to see this relation of Gemma doing sort of fast, local, snappy processing, and then offloading these complex tasks to the cloud. But there is a sort of like train of capabilities. I think someone mentioned to me recently, was reminding me that the performance of Gemma today is that of Gemini maybe 18 months ago or 12 months ago. So there's this constant compression of capabilities into these small models that's pretty remarkable to see.
That's pretty cool. Is there a way to pick and choose as well? Is like, can I make the model even more determined for myself? If, for example, you have a multimodal model like Gemini with like image, video, text. I just want to do text on mine. In the Gemma model that I use locally, can I just use a very focused one, or even a very focused one on a certain topic, like medical information or trains or something like that? Or is this something where I need to take an open source model and train it myself instead of filtering down Gemma, so to say?
Yeah, I mean, right now we provide these sort of like fairly generic base foundation models, and they're sort of fine-tuned to achieve multiple things. I think it's sort of like straightforward to pick one of these models and customize it and fine-tune it for a specific subdomain. But not entirely obvious to sort of like strip out the base knowledge it would have in other categories. We're exploring those types of things. One thing that's very exciting about the Gemma community is we have these variants that are being produced by the internal sort of Google community. So recently we released Med Gemma. There used to be Pali Gemma before for computer vision capabilities, before those became mainstream. So there is a constant sort of stream of variants being built in the Gemma community. And that's sort of how we're approaching this right now.
Cool. So basically, there's a community feedback loop. There's basically people bringing trained, specified models back to you for hosting as well, rather than just like keeping them for themselves. So that's a great concept, because it feels very open source. It feels like a fork of your product, and then people did change to something else and communicate it back to the community, so that people don't solve the same problem in 12 different places, but basically can learn from each other.
Exactly. Absolutely.
How big is the community out there? Like, how many people do you have, or just roundabout? Like, is it growing constantly? I guess Google I/O is always like a spike where there's more coming to it, but has there been a continuous growth over the last few months?
Actually, Google I/O was interesting to me because we launched so many amazing things across not only Gemini, Gemma, but also in the Gen Media space. We announced Veo 3, which is this fantastic, remarkable generative video model that has audio support. And so, in a way, because so many announcements happen, I think the what we announced in the Gemma world probably got a little bit buried. But the community has been growing tremendously. I think it's been a really interesting journey. When we started with Gemma 1, I think it was almost 2 years ago now, 18 months ago. It was a very slow start because Google was quite focused on Gemini, which was the frontier model. And so the idea of creating a parallel community around open models and really engaging developers and meeting them where they are by enabling them to sort of deploy these models in arbitrary ways was a bit underfunded initially. With Gemma 2, I think we passed a really interesting threshold because the model was quite capable. And then finally, more recently, a few months back, when we announced Gemma 3, I think we provided a model that's extremely capable, that I think has remarkable performance on known benchmarks like LMCs. So that's starting to resonate with the community a lot now, and we're basically seeing a constant growing community around these models.
One of the criticisms of AI is a lack of transparency. So often you see like great services, like, oh, look at what the cool thing can do, and then you start using it and you realize it's actually a kind of veiled subscription model. You just basically, for more capabilities, you have to pay like that much and that much per month. Like, how open is, and also dependent on the company, you basically buy a lot of, sometimes it feels like which model I choose, I now have to subscribe for 2 years of services for that company or that company. I guess with Gemini, it's an obvious service offering, but with Gemma, how is it open? Like, oftentimes when I talk to people about open source AI, the weights are open, but that's about it then. But not like the usage of it still incurs some fees that are going on. So what's that like in the Gemma space? And is there something? What does it mean for the market and for developers? Can I build on top of Gemma and make money? Can I basically just use Gemma for free for myself? Where are the limits of that?
Yeah, Gemma is extremely, like, the license is very permissive. So you can really go build, pretty much any application with Gemma. You're free to sort of grab it, fine tune it, adapt it to your needs. So I would say it's very open. The things we don't disclose completely is the sort of like training recipe, and because we do a lot of distillation from Gemini, and so there's some sort of like secret sauce that goes into building such amazing models. But once the weights are out, you can get the inference code, you can fine tune these models. They're basically yours. So I think we really invite folks to go build things. It's great for us to figure out what people end up doing with these models. We're also trying to figure out, what type of amazing use cases we can sort of pack and land in on-device footprints, like a cell phone, for instance, an Android device. So I think to us, this entire approach is working very closely with developers, figuring out what they do, helping them achieve our goals. And by the way, even on the Gemini side, even though these models sit behind an API, we have a quite generous free tier that lets people get going pretty quickly. But I do agree with you that these are different approaches. Like when Gemini sort of gets upgraded behind an API, some developers are less fond of that. They'd rather have control over the lifecycle, and that's where models that are completely open, like Gemma, are quite appealing to them.
Yeah, that makes sense. So AI Studio seems to be the starting point for these systems. Like when I talk to other Google Cloud people, they're like, start an AI Studio, then you can choose the model, then you can choose the bits and bobs and put them together. What are some current features that you're proud of? What developers can do with it? Like, what are the things where you say, like, I saw people get started in 4 or 5 clicks? And on top of that, like, have you seen any implementations using Gemma that really blew you away, where people had like another open source or even a closed project that is built on what you did, where you said, like, this is why I did it. This is why I want people to have some free stuff to play with.
Yeah, I mean, that's a great question. So first of all, I'm super excited about AI Studio. It's been this sort of like magical developer product we've been building for a while now. And our main approach with AI Studio is we're trying to have this sort of like super low bar portal for developers to come in and figure out everything they can do with our models. We feature multiple models there. Gemini is sort of the top one because we want AI Studio to be a way to figure out what Gemini can do behind the API. We also have Gemma more as a sort of like quick way of getting started and understanding what it can do as well. And then we have the Gen Media models as well. We've added support for Veo, which is the video generation model. We've added support for Image Gen, which generates images, and Lyria, which generates music. So all these can be found in AI Studio, and you can sort of play with them and then drop down to the API and go build applications with them. We've built and released quite a few exciting things for I/O this year. The list is quite long, but maybe my top 3, number 1 would be the code generation for web applets. So if you go to AI Studio in the Build tab, you'll see, a way to essentially generate web apps by talking to Gemini. What's really great about the way it works is it taps into Gemini 2.5 Pro, which is our strongest model for code generation. It sort of like processes your prompt, and then it starts structuring the app by creating multiple files. So, the TypeScript file, the HTML, CSS. I'm always blown away by how it ends up structuring the entire application automatically. And then the sort of like, there's a few magical bits, like the fact that once it spit out the app starts running in the background. It looks at the error log and it starts correcting errors, and it uses Gemini's thinking and reasoning capabilities to sort of like work its way through this. And once it's done, you typically, get a working application. Sometimes a few things are sort of missing. And then you can continue chatting with Gemini to sort of like fix parts of the app and get it to completion. And once you have the app and it works and you're happy with it, you hit a button and you can deploy it through Cloud Run as a sort of like long hosted app. So to me, this is super cool because it really lets you understand like what these models can do in terms of like code generation, how they can help you sort of build these apps, and we're lowering the bar more and more. I've been able to like build these amazing sort of like teaching applications for my kids, let them draw something, and then Gemini would turn that into a story. Very cool things like that. The thing that's great about this, so there's many startups doing such products right now that are pretty amazing. The thing that we're trying to do with this build section of AI Studio is we're really trying to get these apps to use the Gemini API so that you can sort of automatically find ways of using the Gemini API in the app itself. So it's a bit recursive. And we've seen a lot of adoption, lots of pickup of folks deploying apps to Cloud Run. So very exciting stuff. The other part that was very exciting is we're building up our live API offering. So we have this live mode where you can use Gemini and talk to it in sort of like natural audio. You can also share your screen or share your camera. And because Gemini is natively multimodal, it sort of understands everything it sees on the screen, in the camera. And for I/O, we released native audio mode. So you can also ask Gemini to change its accent, pick up a French accent, and start talking like me. So there's a lot of like interesting things there. I think we're still at the beginning. And then jumping to your other question on the Gemma side, what we've seen people do is Gemma is pretty advanced things now where they're starting to build completely local agents that can look at visual content, rely on audio as well, and start enabling sort of like local tool use with the local apps in the phone. So pretty exciting stuff. Like things that only a year ago were only sort of doable on the server side, and now they're getting compressed into on device. So that's really cool to see.
That sounds interesting. I like the idea that it actually does the error logging and actually recursive development of the app that's doing it there. One thing that I only played with a few of those tools so far. What drove me nuts that was not Google's thing right now, it was something else. What drove me nuts is like I had one change to do, like a button wasn't big enough or something like that. And I said, like, can you change the button to another size? And it started writing the whole app from scratch.
Oh, yeah.
It started bringing in the same npm modules again. Is there a more iterative approach to this one? Like right? What I would do as a developer, just change that one component and not start from scratch every single time, because that always felt a bit like wasteful to me.
Yeah, no, completely. So unfortunately, not right now. Like in the current app, it's very much what you describe. Like every iteration is this sort of like holistic, sort of like rethinking the entire world. But we're thinking through ways of doing that. There's ways you could do it by sort of like selecting, companies like Cursor, they do this really well, where you can sort of like select some parts of your code and go sort of use the AI on that localized piece of code. I think there's probably ways to automate that completely, where you would sort of ask Gemini to, focus on that particular button, and it would identify the code in question, and then we would just modify that. I think we will get to that stage fairly soon.
Pretty cool. I like the whole. I liked when AI is basically invisible. I like, for example, I'm an Android user since day one, and I love in Google Photos, if I look for a dog, it shows me all the pictures of dogs. Although I didn't tag them, it actually analyzed the pictures and said like which one is a dog and tagged them in the background, I guess, or something like that. Same with like Spotlight on Mac OS or like things in searches in Windows. I can say like, show me the files from 3 weeks ago that are bigger than 2 GB in a natural language, and it actually does that on the file system for me. Do you see that like with models getting more and more local, like Gemma, that this will be even more of a thing, that we basically, that in the future we might not be thinking about file systems at all anymore, but we just be thinking about data on our devices and it finds it wherever it is?
Yeah, I mean, I think it's sort of like hard to realize where we're going to end up, but my sense is that the notion of app is going to end up disappearing as well. We're going to end up having, there's all sorts of mock-ups and early sort of like proofs of concepts of this being built now. where you have this sort of completely contextual OS, if you will, where there's an AI and it's sort of interacting with you through natural modalities, and then the apps are entirely sort of rendered dynamically by the AI based on what you want, based on what you're looking for. And so in this world, I think the notion of like, there might still be a file system that's sort of like buried somewhere in the OS to support it. But as a user, you won't really be touching it at all anymore. I think we're going to end up getting to something like that. By the way, this thing about like image parsing, and it's really interesting because it's sort of going back to some 15 years ago when I had my startup. I joined Twitter. It's really the dream we were chasing. Then we were sort of like trying to use these neural nets to process collections of images on the web, personal photos, and run them through these neural nets to sort of like automatically describe them. And we're sort of doing exactly the same today, except the models are so much better, by orders and orders of magnitude, that the granularity of what you get as a description and the way the model understands it is completely mind-blowing. And one thing I also forgot to mention, in AI Studio, I invite you to try something else. We also added support for these native image in, image out capabilities in Gemini. And we have something similar with Veo, where you can essentially import your own personal photo, like of yourself, and then ask Veo to sort of turn that into a video with, say, an animal playing on your head. And the results are completely mind-blowing, So I think these models are getting to a degree of understanding of images, text, language, and being able to produce it and sort of like being more and more sort of like steerable to interact with this data, that I think we can completely rethink what we build on top of them.
It's interesting because these filters have been in Google Meet for quite some while. So, and I mean, before that as well, we had them in Instagram, we had them in TikTok, we had all these things. And I always saw them, and I saw people and kids using them, and I'm like, oh God, I know how much computation is behind that, how complex it was to make that squid on your head be on the same place and move its eyes like you do. And it looks very simple, but there's so many things in there. But the as you said, like 15 years ago, we were like, okay, that's like 2 months of computation to get that thing done. And now it's more or less in real time, recognizing it on your phone camera and actually putting the thing there. It's quite amazing that you can do these things. They do use a lot of energy, though. Like, that's another thing that I found interesting, that when you look at AI research, that battery life, for example, on Android, there's a lot of like AI research into how to make the battery behave differently and last longer than it did before. And these are the kind of invisible things that I'm very excited about.
No, absolutely. I mean, and that's why I think there's two interesting things happening. One is, I think we need to continue relying on server-side models for a lot of these tasks, because it's if you really want to get the absolute best AI experience right now, like processing continuous streams of audio and videos, the compute power is just too much for a local device. But on the other side, what's happening is that you have this constant compression of capabilities. We're getting better and better at producing small footprint models that are actually extremely powerful, and I think this is going, in terms of like progress, it's going extremely fast. The fact that we're compressing something we had like 18 months ago into something that fits into a mobile device today. But then I think there's a huge opportunity for continued sort of like innovations on the hardware side, chip design, for sure. There's a push for more memory on these devices. And so the more these things happen, I think the more we'll have the right building blocks to actually build these applications. But again, I think we're always going to want to have some kind of delegation to a cloud side device, do the things that need to be real time locally, and offload like more complex, long thinking type tasks offline.
Yeah, or shard them and calculate them bit by bit, rather than in one long thread that dies on your camera and your battery basically is like empty in half an hour. So agents are a big thing that you talked about as well, and it's a huge buzzword. Everybody talks about agents right now, and some people talk about that artificial general intelligence is already around the corner because of those. So how true is that statement that we're closer to AGI? And more importantly, do we really want machines to think and act for us all the time? I mean, when I hear things like, we have an agent now that can use your credit card to buy random things online for you, I'm like, that's like a dream come true for a malware creator to take over that thing and do it for me, right?
Yeah, I mean, okay, so maybe starting from the top, I do agree with you that the agent world it's such a marketing, it's hard to know what we even mean by that. To me, the difference between a model and an agent is the concept of agency, which is literally this idea that you're empowering the model to take action autonomously. I do think there's tremendous risk and downside in building these types of agents in sort of like open-ended ways. What you described, you have an agent that's not completely mature. You haven't fully understood like the potential like injection risks. Why would you go deploy an agent and give it your credit card and let it run freely on the web? That's so I think we've got to be careful about this. But on the other hand, I think very strongly that we need to build autonomous agents because it's going to be the way that we end up relying on AI to go solve extremely advanced tasks, including things like deep innovation, coming up with new solutions in the medical space, new drugs, coming up with new designs for I don't know, mechanical projects like a new engine design. I think we have to enable the systems to act as agents. And by that, I literally mean, you're putting a model behind some kind of like, you're giving it access to the real world through tools and very well-defined APIs. I think the key thing is going to be to constrain the access and the sort of like worlds these agents evolve in so that the risks are sort of bounded. And so again, I think to me, it's like if you build an agent that has a ton of agency, but the tools it's interacting with is, for instance, a computer with a CAD design tool and no access to internet, and it's been taught to essentially come up with innovative designs for engines. And you let it run wild, like tons of agency, go explore these ideas, and it will come back 24 hours or 48 hours later with new designs that it's tested and sort of like run in a local simulation. I think that's extremely good. So lots of agency, but sort of like constrained environments to actually do things, versus the idea of, we're going to build an agent that's like, connected to the web, access to bank accounts, and go redefine, the way politics is implemented. That's too much, So I think we can differentiate agency and extreme amounts of agency and the sort of open-endedness of the world these things are going to interact in.
One thing I see people wrongly attributing is like an agent to them is like an AI that goes out and solves problems for me, surfs different websites, finds the best prices for an hotel room, and then gives it back to me. That to me is automation, not agency. That is basically a script running, much like Automator on macOS used to be, that allows you to do these things. And it feels like that there is a lack of education what the agency really means, that it's not an agent like a butler that you send out to shop for you, but it's a thing that actually has its own right to change the way it approaches things rather than asking every single time. Is that a too simplified view of it, or is it something that you would subscribe to as well?
I think there's just, it's an ill-defined term, to be honest. And so I sort of like, I think of both definitions as valid. A system that is able to pursue a goal on its own and is sort of free to use its underlying subsystems to achieve that goal is some kind of agent. But I do agree with you that, and by the way, it's the same is true for artificial intelligence. There's many levels, right? Like we started using the term artificial intelligence, 70 years ago in very sort of limited environments. A system that was able to play chess autonomously and then win against a human was a form of AI. It was just an extremely narrow one. So that's why we introduced the term AGI as well, to describe forms of intelligence that could do many more things with the same underlying sort of algorithm. So I think there's levels of agency as well. I do agree with you that I think the agency that we're now talking about that's sort of worrying, but also very high potential and exciting, is the one that's truly able to sort of maybe redefine its subsystems, self-improve, continuously learn, so that it really sort of gets better and better at solving the goal you've asked for. But I also agree that I think we need to be careful and remain quite narrow in how we're sort of deploying these agencies. I think for us, it's very exciting to go build AGIs that are then deployed in very narrow domains to help us solve extremely complex tasks, rather than trying to build something completely open-ended, like, a humanoid that has exactly the same sort of, ability to interact with the world as us, and then let them roam freely. That seems reckless.
It feels very much that we're confused by science fiction movies over the years. It always cracked me up in science fiction movies when you had robots that were like bipeds walking around like humans and even showing like emotions. Like I think Star Wars was one of the biggest annoyances when the droids started saying "oh" and were afraid of things. And you're like, why would you build a robot that's afraid of things? If that that it feels like we're always trying to get into that uncanny valley of building things that look cool. At the same time, the real innovation happens with like the machines that look like proper machines and are meant to do one task. I like robots in car factories that are just one arm that put thing one next to another that humans shouldn't do. But we seem to be having a race of like creating the most humanesque things that are out there. At the same time, it feels like there's such an inefficiency to that. Like two robots talking to each other makes no sense. They have actually faster ways of communicating with each other because they're two computers. Yeah. Humans talking to each other, that's where a lot of communication breaks down as well, and we lose a lot of information. But it seems like there's like ubiquitous computing and general artificial intelligence is something that we put together right now into this future dream of Star Trek. We talk to the computer and then he solves problems for us in an agentic way and comes back. Yeah. Do you think we're distracting ourselves by trying to be too Star Trek-y rather than like building things, like you said at NYU, focused on one thing and do the thing well?
Yeah. I mean, I think there's multiple aspects to this. I think there's one aspect, which is the ability of these AIs to interface with us humans is extremely useful and convenient. And I think that's what we saw with ChatGPT in the early days. ChatGPT started taking off because there was really this sense of you can have a natural dialogue with this system and not have to sort of like, type perfectly, or it's just like you're talking very naturally and the system gets it. So having an IO of these AIs that's able to sort of like, meet humans where they are is very important. And I think that's what leads to all these these side effects that you describe, right? That folks then get quite obsessed with, building things that are actually very human-like on multiple aspects. But I do think that actually there's other aspects that are also convenient. Like when you look at the idea of building robots that are actually human-like with 2 legs, 2 arms, actual sort of hands, that's actually quite convenient too, because it turns out that if you build the robots the way we're shaped, then they're going to be able to go do all the things we do as well and live in our world. To me, I see that as a sort of like interface. It's whereas if you're going to build these robots differently with a different IO, then they're not going to be able to deal with our world. By the way, the same is true with self-driving cars. Building self-driving cars that are retrofitted to really work the way we work, with our cars, like Waymo did it, is good because you don't have to reinvent infrastructure. They're going to be able to use the roads that exist, right? So I think there's a notion of IO, but then IO aside, the way the AIs would sort of interact with each other on the other side, they don't have to use our IO, and they could sort of exchange mind state through tensors directly. They could do all sorts of things that we can't do as humans, and I think we should absolutely explore that. By the way, in a way, it's how we train the systems. They live on tens of thousands of TPUs with replicas of their weights, and the way we train them is there's a ton of sharing across them. So you can think of that as sort of like very efficient, digital mind state sharing, which us as humans can't do at all, right? But I do think that, the problem of IO and having these machines able to live with the world we've created for ourselves is pretty important.
So as a developer with no money, I have lots of ideas, but I don't have any money. what do I do now? How do I get started? And what would you like? What would you say is the fastest way to hit the ground running and just play with things?
Yeah, I mean, so the good news today is that, and again, I remember like the days I got into artificial intelligence, neural nets, there was almost nothing. By the way, me and a few friends built this library called Torch back
Oh,
then, which eventually became PyTorch.
yeah.
And I look at where we are today, and there's such a sort of like, you have so many tools, so many amazing libraries. The Python ecosystem is so vibrant. So I would say, start with open models, because it's a great way to sort of like get going with some kind of like locally deployable thing that you can run yourself. I think there's great platforms out there like Hugging Face, where you can sort of like easily get code that's very easy to understand, very easy to sort of compare and contrast models from different vendors, which I think is really good as well. And then if you're starting to get into, now I want to build actual applications and host them, then, I think what we provide in AI Studio is pretty appealing. You can sort of get going with Gemma on one side. You can start tapping into the Gemini API. There's a good free tier so that you can try a lot of things for free initially. And then ultimately, if you're going to be building apps that run locally, I think you can stick with open models, and that's very cheap. And if you need to build things that are more powerful, you probably need to graduate to an API at some point.
Mm-hmm. What about ownership? Like, what about I mean, using the open model, I guess the license is like any other open source software. But I mean, you can do a lot of horrible things with AI as well. Like you do like deep fakes of other people and these kind of things. Is there any, I mean, on the Gemini side, I think this will be very much obvious, but have you seen any abuse of Gemma systems? And do you think the community can do something about this, or is this something that you control yourself somehow?
So we have some terms in our Gemma license. I mentioned that the license is very permissive, like folks can go build apps. We have a few terms in the license that sort of restrict, abusive cases of apps being built. I don't think we've seen anything right now. So, I'm pretty sort of positively surprised by what the community is building. And so, so far it's been nice.
What's one thing that you're looking forward to that developers can do? I mean, of course, they can use your products and do something with them, but can they also contribute back to the system itself? Is there something that costs a lot of time and effort for the company right now that you would like a community to do? I'm going back to my former job where I was an open source at Microsoft, and it was tricky to get people to contribute because they basically either said like, you have enough engineers, you can do it yourself, or they said like, I'm not good enough to actually contribute because I don't work for Microsoft, Google, or whatever. Like it always felt like you want to get people to be part of what you do, but it was hard to get them onboarded because they were like shell shocked, or like they were like, I don't know, they were just like, I'm just not good enough. So what would you like people to do to contribute more?
I mean, I think it's a great dilemma for sure. I would say from where we are right now in this arc of progress is moving so fast. The amount of sort of compute and capabilities we're throwing at building these models, I would sort of tell developers outside of these large companies to sort of like not try to go build foundation models. It's too hard. It's just, it's really involved. I mean, but what I would say is there's probably two main things that the community should be exploring, and I'm often surprised by what they produce actually. One is the sort of user interfaces, so the ways that applications can sort of like use an AI to interact with humans and enable new ways of interacting with data. I think there's so many things to explore there. One example that was not built by the community but by a team at Google in Google Labs is this application called Notebook LM. I don't know if you've tried this, but I would think that the community could come up with maybe less exciting versions of this. But Notebook LM was quite revolutionary. It was this idea of you're going to be able to import your data sources like a video, PDFs of papers, websites, and then you're going to ask the AI to process all of that for you and have a natural sort of conversation with this content. And even generate a podcast and then go listen to the podcast. And now they've added the capability where you can actually interrupt the podcast host and ask them questions live, which to me is like mind-blowing, because everything is generated, on the fly. And so you can sort of build these things on top of our APIs as a user. I think folks should be very creative to try to like explore the edge of what can be built on one side. And then the other aspect is there's also the sort of fine tuning. I think folks can grab Gemma and build variants for subdomains. I'm not sure. I think that seems quite realistic to me as well and interesting. And I would love to see more of that.
So is there a place in Google to actually publish those, or would be Hugging Face the place to put those things to those other models?
Yeah, I think Hugging Face is a great place for that. We collaborate with them very tightly. Like when we release Gemma, we always work with them. I think that they're a good partner for this.
Cool. Well, any last words from you for our community? What makes you excited? What do you think the next step will be? And how can we impress you, and what do you want from people?
I would love to, the main thing is please go on AI Studio and tell us what you want to see there. We're trying to build this place as a sort of like, really low bar portal for developers to understand what can be built with these Gen AI models, Gemini, Gemma, the Gen Media models. So the more feedback we get there, it helps us steer what we do with this platform so much. Then, of course, the API itself, what should we add to the Gemini API? This is extremely helpful to us. And so we'd love to hear more about this.
So you heard it, folks. That's how to do it. You can send it in as text. You can sing it. There's a video. Multimodal is supported. Anything can be turned into text right now by the models. So that was Clement Farabet from Google. So thanks very much for being on Coffee with Developers. And we're going to now start editing this, publish it soon, and then we meet each other at Google Studio, I guess.
Thanks a lot, Chris. I appreciate it.
See you soon. Bye-bye.
Bye-bye.
That was Coffee with Developers. If you want more of this, subscribe to the newsletter. Every Friday, we're releasing something there. You can go to the watch section of WeAreDevelopers and find all the old versions of Coffee with Developers, lots of them also from the Google Cloud team. And yeah, hopefully I see you at one of our events soon. Thank you very much for watching. And thanks again, Clement Farabet from Google. See you all soon.